Climate change. Professor Platt. Well, thank you for coming. I'm a geologist, and the one thing that we miss out on in looking at climate change is the past. Climates have always changed. Climate changes in the past have been greater and faster than anything we experience in our lifetime. And sea levels have always changed. Not by the modest couple of millimetres that people are having conniptions about, but we've had in the past sea level changes of only 1,500 metres. That's a sea level change. And if we look back in the history of time, the atmosphere once had a very large amount of carbon dioxide in it. It's now got less than 0.04%. Where did that carbon dioxide go to? It went into chalk, limestone, shells and life. And we've been sequestering carbon dioxide out of the atmosphere for only 2,000 to 500 million years. This planet has been degassing carbon dioxide since it first formed on that Thursday 4,567 million years ago. Carbon dioxide is a natural gas. It has dominated the atmosphere for an extraordinarily long period of time. And we now are at a dangerously low level. If we halved the amount of carbon dioxide in the atmosphere, we would have no terrestrial plants. Carbon dioxide is plant food. It is not a pollutant. To use words like pollution with carbon dioxide is misleading and deceptive. But the past gives us a wonderful story. In the past, we've had 6 major ice ages. We are currently in an ice age. It started 34 million years ago when South America had the good sense to pull away from Antarctica, and there was a circumpolar current set up which isolated Antarctica, and we started to get the Antarctic ice sheet. We've had periods of glaciation and interglacials. We are currently in interglacial. And during that 34 million years, we have refrigerated the Earth. But for less than 20% of time, we have had ice on planet Earth. The rest of the time, it's been warmer and wetter. And there's been more carbon dioxide in the atmosphere. And what did life do? It thrived. 6 of the 6 great ice ages were initiated when the carbon dioxide content of the atmosphere was higher than now. In fact, up to 1,000 times higher. So we have from the geological evidence absolutely no evidence that carbon dioxide has driven climate. For some odd reason, the major driver of climate is that great ball of heat in the sky, which we call the sun. You heard it here first. It's really quite unusual. And we change our distance from the sun. Every 100,000 years, our orbit changes from elliptical to circular. And we have a cycle of 90,000 years of cold and 10,000 years of warm. We're in one of those warm cycles now. And every 43,000 years, the axis of the Earth changes a little bit. And every 21,000 years, we get a bit of a wobble. Each of those orbital events put us further from the sun. Every now and then, we get bombarded by cosmic rays coming from a supernova eruption somewhere out there. And if the sun's magnetic field cannot drive these away, we start to form low-level clouds. We've got extremely good evidence that this process has been going on for a very long period of time. Every now and then continents start to move, and they move at very rapid rates. They move about this much every year. And at one time a continent can be over a pole, at another time it can be at the equator. Those moving continents change the major heat balance on the Earth. And that's the ocean currents. The oceans carry far more heat than the atmosphere. Every now and then, because of major geological processes, we'll get a great bulge on the ocean floor of new volcanic rock. That changes ocean currents. Every year we have 10,000 cubic kilometres of seawater that goes through new volcanic rocks in the ocean floor. That exchanges heat. The reaction between seawater and the rocks stops the oceans becoming acid. When we run out of rocks, the oceans will become acid, but don't wait up. It will be a long time. We see 1,500 terrestrial volcanoes on planet Earth. We only measure 20 of them, and very few of those measurements are really accurate, but they tell us that a little bit of carbon dioxide leaks out of those volcanoes. But what we don't hear is that there are at least 3.47 million volcanoes on the sea floor which leak out huge amounts of carbon dioxide. We have got pools of liquid carbon dioxide on the sea floor. So, early Earth's carbon dioxide, where did it go? It went into rocks. Where did it come from? It came from rocks. What did it do to the planet? We did not fry and die. We didn't have runaway greenhouse. Well, that's just geology. That's not important. So let's look at more modern times. In more modern times, we have drill cores that have gone through the ice sheets. Snow, when it falls, captures some air. That air is then trapped in the ice. We can later extract it from drill core and measure the amount of carbon dioxide in the air. And we can see with our cycles of glaciation and interglacials that when we finish an interglacial event, then we release carbon dioxide some 800 years later. So what's that telling us? It's telling us that temperature is driving carbon dioxide, not that carbon dioxide is driving temperature. Oh yes, but that's only hundreds of thousands of years ago. Forget that. Well, let's go to more modern times. We've been measuring temperatures accurately since 1850, and the accuracy is plus or minus 1 degree Celsius for those ancient measurements. We are being told that this 0.7 degrees Celsius rise is going to create a disaster. I've only got to move over to here, and I've had a 0.7 degree Celsius temperature rise. Where do you people go for your summer holidays? You go to a warmer climate. We are creatures from the Rift Valley. We like warm climates. If someone from Helsinki moves to Singapore, there's an average temperature rise of 22 degrees Celsius. Singaporeans don't drop dead in the streets from the temperature. So we are creatures of warm climates, and we've been measuring temperature, and we have seen a slight warming from 1860 to 1890, and then a slight cooling until 1910, then a warming until 1940, so much so that the Northwest Passage was open, then a cooling until 1977, and then a warming until the end of the century, and now we're in a period of cooling. So we've had these cycles of warming and cooling. Strange that these cycles are actually related to changes in the heat balance in the oceans. So we have these 60-year cycles over a long warming event. We are in a period of global warming. It has been warming since the Maunder minimum 330 years ago. These were the times when you had the ice fairs on the Thames. These are the times when the Dutch masters painted hoarfrosts and bitterly cold conditions. That was the time when the sun was a bit inactive and we had no sunspot activity. So we're in a long period of warming, and one of the questions that I ask in this book is which part of the last 330 years of warming is due to human activity and which part is natural? These are questions that kids should ask their school teachers, and they're deliberately unanswerable questions.